Okay, so this is going to be a continuation of our lesson, starting on page 18, example number 7. So this one here, we have determine the equation of g of x in the form of y minus k a of b times x minus h, given the graph of the function. Okay, so let's see. So this is the f of x, and then now this is the g of x. They're telling us this is the old, this is the new, and our question is, how do we figure out the new equation? So let's see here. Just by inspection, what do you think is happening in here? Just by inspection, what do you think happened here? So you're probably thinking that, oh, the graph is going this way, but then now it's down here, so there's a reflection in the x-axis, right? Okay, good. Yeah. What else do you notice? Horizontal stretching? How do you know there's horizontal stretching? Because when you look at this, A and B is 1 unit apart. And then now A and B is this far apart. So there's horizontal stretching right there. And then it has to go down a certain units. There's a vertical translation down. And there's also a vertical stretch. So it got reflected down here over the x-axis. But you see the A and the B vertically, that's how far apart they are, 1 unit apart. But then now look at how far apart they are vertically. So there is a reflection over the x-axis. That one is very obvious. There is a stretching horizontally, there's a stretching vertically, and then also there's a vertical translation going down. Okay, so let's try to do all that stuff. Okay. So what we need to do first is to, I'll just write down page 18, example 7. So the very first thing we're going to take a look at, is there a horizontal stretching? So because we are looking for horizontal stretching, we want to make sure that we have the points and see if they stretched out horizontally. So if we take a look at the horizontal distance from A to B, okay, horizontal distance from A to B, that's this many unit apart. It's 1 unit, right? 1 unit. Now let's take a look at the horizontal distance from A prime to B prime. From A prime to B prime, how far are they horizontally? So A is here, horizontally. We're only doing horizontally, then now it's 1, 2, 3, 4. 4 units apart. Okay, so that means there's horizontal stretching by a factor of 4. Now, because it's a horizontal stretch by a factor of 4, that tells us that Therefore, I'm writing everything down, and this is what I'm looking and also what I'm thinking. So because there's a horizontal stretch by a factor of 4, that means B is equals to 1 over 4. So the B is going to be 1/4. Right? The factor is 4 over 1, so the B must be 1 over 4. Now, let's see if we can figure out, what about the vertical? Is there a vertical stretching? Well, let's see here. Vertical distance from A to B. Okay, let's see, vertical distance, A to B. Vertically, how far are they? It's 1 unit, right? 1 unit. And then from A prime to B prime, there's also 1, 2, 3, 4 units. So, vertical distance from A to B is 1 unit. So therefore, let's see, write it down first. Vertical distance from A prime to B prime, that's 4 units. So 4 divided by 1, so that's going to be vertical stretch by a factor of 4. Okay, well, the vertical stretch, that's the A value that we're thinking about. Therefore, A is equals to 4. Yeah. Okay, so there's a stretching. Now, another thing too is that because this is flipped down here, so there's a reflection in the x-axis, that tells us that the A is also a -1. So there's also a reflection in the x-axis, so A is really -4. Okay, A is equals to -4. Okay, good. So we figured out the B and we figured out the A. So what happens now? What's going to happen is that we're going to first pick a point. Okay, we're going to pick a point B. We're going to try to pick a point that's not on the x-axis and that's not on the y-axis, because when we stretch on if it's on the x-axis and if we stretch it horizontally, that's not going to move, and if we stretch vertically, if we stretch vertically, it's not going to move if it's on the vertical stretch, right? The points on the x-axis is not going to move, and then on the y-axis it's not going to move if we stretch horizontally or compress horizontally. So what we're going to do is we're going to pick a point that's not on the axis. Okay, so pick a point. We're going to pick a point B. So if we pick a point B and we know that B is 1/4 and A is -4, where would that point be located now? So pick a point B, which is at 1, 1. Okay. Of course. Yeah, it's gonna, because I showed that last time. If I could find the, yeah, I'll find the page and then I'll show you why that is. Okay, so we're gonna pick a point 1, 1, and now where is 1, 1 after? Where is B after we apply the stretching, compression, and reflection? Okay, so we're gonna try to figure out where that B is after we've stretched it and compressed it and reflected it. So it used to be 1, 1. Now because B is equals to 1/4, so it's 1 over B times X, and then A times Y. So 1 over B is 1/4 times X, and A times Y is negative 4Y. So where would that point B going to be? So 1/4 times X is going to be 1/4, and negative 4 times Y is going to be negative 4. So this 1, 1 is now at that 1, 1 oh no, back up, factor of 4, 1 over B, so that's going to be 4x. Set a factor of 4, so it's going to be at 4, negative 4. B is 1/4, so if I go 1 divided by 1/4, that's 4. Is that okay? Is that good? Because they said the factor of 4, we said that at the beginning, so B is 1/4. So if we put 1 over 4, it's going to be 4. So factor of 4, we already know that. So the new B prime, is now at 4, negative 4. So B prime is going to be 4, negative 4 here. That's not where it is right now. Okay, so what happened here is that, so this is B prime after stretching and reflection but that's not what happened only. It went from here horizontally, it's in the right place, but vertically it's not. So that means it went down further by, how many units is this? 1, 2, 3, 4, 5. 5. So it went down 5. So as well, the graph went down 5 units. Went down 5 units. So if because it's 5 units down, that tells us that the K value is negative 5. The K is negative 5. So now putting it all together, y minus k equals to a times f of b x minus h. So k is negative 5 So y minus negative 5, so y plus 5. A is negative 4, so negative 4. F of B, B is 1/4 times x. So this graph, after all of these transformation, is now down here. Okay, is that good? So that one is a long one because we don't know what's happening. We have to calculate the factors. We need to see what's going on in here. Okay, good? So far, okay. I'm gonna do the last one because we don't have a lot of time. So we'll do the last one. Determine the equation of g of x from y minus k a of b of x minus h. What's going on in here? So this is the original one, and now it's like that. Now looking at that, can you see what's happening in here? Reflection in the x-axis, so it reflected down here, so it's into the x-axis. That's why it's vertical reflection. Okay, so there's how do you know reflection in the reflection in the x-axis? Because it flipped that way. Do you see also the reflection in the y-axis? Because the B is on this side. If you reflect it, it should still be in this side, but now it's on the opposite side. So it flipped down and then this way. And then a transformation up too. And then also horizontal. And so there's so many things going on in there, right? So we're gonna break it down piece by piece. Okay. So we go here. Example 7, letter B. Let's see if there's a horizontal stretching or compression. So horizontal distance between A to B. How far is A to B horizontally? It's 1 unit, right? So 1 unit. What's the horizontal distance from A prime to B prime? Horizontal distance from A prime to B prime, that's also 1. Yeah, so 1 and 1, nothing changed, no change. So therefore, no horizontal stretching or compression. But it's obviously there is a reflection into the y-axis, because the B is now over here when the B is over there, right? So I don't know if you could understand that piece. If we go this way, B is over here, and if we reflected horizontally, so this is the B, it will now be in the same place but on the opposite side, the B prime. So there's a reflection into the y-axis. Okay, where's my paper? But, oops, wrong color. There is a horizontal I'm not going to use that word. There's a reflection into the y-axis. Okay. Okay, so what does that mean? There's a reflection in the y-axis, so that means A is equals to -1. Flipped over. Yep.
So, this one is same, but you just look in the part into that, like something, so right?
Yeah.
Okay.
So there is a B. Oh, sorry, the B. Yeah, B. B is -1. Now let's take a look at the vertical distance from A to B. Okay, so this is B is equals to -1. Vertical distance from A to B, where's my graph? Vertical distance from A to B, that's 1 unit. And then now vertical A prime to B prime becomes 2, right? Becomes 2. So vertical distance from A to B and vertical distance from A prime to B prime, now it's 2. Okay? So that one is obvious that there is a stretching. So vertical stretch by what? How much factor? By a factor of 2. And also,
How do you get that to A prime to B prime?
yeah, A prime to B prime is 2 units, so it's vertically stretched.
So, what is it?
Yeah, you're right there.
Which one is the original?
The original would be A to B. A to B, yeah. This is the original. And then this is the new one. So if you go new divided by the original, so that's going to be 2. Right. So it got multiplied by 2. Is that good? Also, there's a reflection in the x-axis. Also, there is a reflection in the x-axis. So, what does that mean? A must be a factor of 2. That's a vertically stretching, a factor of 2. And there's a reflection into the x-axis, so there's a -2. -2. So far, so good. So B is -1, A is -2. Now we're going to pick a point. We're going to pick a point that's not on the axis. Okay, we're not gonna pick the one on the axis. So let's pick the B. B is 1, 1 again. Pick point B. Oh, B, not B prime. B, which is 1, 1. And then we're gonna ask ourselves, okay, after we've reflected, we've stretched, where is B now? So where is B after we reflected and stretched? Okay, so 1, 1. Now, what did we say? 1 over B times X, comma, A times Y. So here, B, 1 over B, so 1 over -1. So it's going to be -1 times X. And then A is negative 2, so it's negative 2 times y. So this 1 point is going to be at negative 1, negative 1, negative 2. Negative 1, negative 2. So negative 1, negative 2. So this point here, after it's been reflected, it should be at negative 1, negative 2. Negative 1, negative 2. But then we're saying, well, that's not where it is. So this is, I'm going to put it here. This is the B after reflection and stretching. But the final B is up here. So we've already dealt with reflection and stretching. How did it get from here to here? And it has to be the translation, moving up and horizontally left. So how many movements is that to the left? So we go 1, 1, 2, 3, 4, 5. Okay, so left 5. And then, how did it get up there? How many units? 1, 2, 3, 4, 5, 6, 7. Up 7. Okay, so our final destination would be equation, new equation. What did we say? Left 5. Where's that thing? Left 5. So that means h is equals to minus 5. And then we said up 7. So that means k equals to 7. So we got everything now, right? Y minus k equals to AF of B times x minus h. We're going to put those values in here. So y minus k, well, k is 7, equals A. A is negative 2, so negative 2. F of B, B is negative 1. X, and then h is negative 5, so it's minus negative 5 plus 5. Oh, that's a long one. Okay, that's a long one because we have to determine if did it really stretch, what's going on, how did it get from there to there. It can't be all translation, right? It can't be all translation. There's some stretching involved, reflection involved, and so on.
Can we start solving the shifting? Can we start solving shifting? Because I saw you are just starting stretch or compression, then you're doing the
Yeah.
shifting. So
Yeah. Oh, can you start with shifting?
yes, it does.
No. We're going to start with stretching and compression and reflection, and then the horizontal translations and vertical translations. And it's like following the orders of operation, right? So when we do the orders of operation, we multiply first, right? And then before we add or subtract. So same thing in here. We're going to do the stretching and compression because that's where multiplication happens before we do the translation, which is subtracting and adding. This one here? Okay. Because of this one in here, what's happening is that distance horizontally from A to B is 1, and for A and B, and A prime to B prime. So I'm gonna, maybe I should do it like this. The original function looks like this. That's what it started off with. So I'm gonna just put a B there so I know that's what we're talking about. I think it's obvious that it's flipped down, right? Yeah, so that one is not a problem. So if I flip it down like this, since it's reflected into the x-axis, okay, let's see where the B is. The B is right over here. And then it got flipped. Yeah, so it's all good? Okay. There you go, everybody. Thank you.